Section 3.2, Radians and Degrees. In this section, we will look at the radian measure definition, converting from degrees to radians, and converting from radians to degrees. Radians measure definition. We're going to write our angles as real numbers, so that will be not in the degree form. And this form we call the radian measure. James T. Thomas was the first one who introduced the term radian. And the radian measure will allow us to graph the trigonometric functions on the rectangular coordinate system, where the units on the x and the y-axis are given by real numbers. Definition. The radian measure. If a central angle theta in a circle of radius r cuts off an arc of length s, then the measure of theta in radians is given by theta equals s over r. And this formula can be rewritten as s equals r multiplied by theta. For the case that s is the same as r, if s equals r, therefore the angle theta, which is s over r, would be 1, and this will represent 1 radian. See the diagram. The radius is equivalent to the length of the arc length here. So this angle theta is 1 radian. First example, we're going to find that if theta is a central angle in a circle of radius r and theta cuts off an arc of length s. For r equals 3 centimeters, s equals 5.1 centimeters, find theta. Recall theta in radian is from s divided by r, or s equals r times theta. Part 1, we are going to find theta. Use the formula theta equals s over r. S is 5.1, unit is centimeter, divided by r, which is 3, unit is centimeters. Centimeter, centimeter, the unit cancel. Therefore, the theta is 1.7 radian. Number 2, for r equals 1 over 4 foot, theta is 3 radians. Find s from the formula s equals r multiplied by theta. The r is 1 over 4. Unit is in foot. Multiplied by theta, which is 3 times radian. Recall the radian is the unit less. That means the units cancel out. The product of 1 over 4 and 3 give us s equals 3 over 4. Unit is in foot. Next example, s equals 12 feet and theta is 120 degrees. Find r. From the formula s equals r times theta, we can rewrite it as r equals s over theta. Recall the theta must be in the radian mode, not degree. So we're going to come back to this problem when we know the conversion of the theta from degrees to radian, radian to degree. Let's see this example. Two cities are approximately 350 miles apart on the surface of the Earth. Assuming that the radius of the Earth is 4,000 miles, find the radian measure of the central angle with its vertex at the center of the Earth that has one city on one side and another one on the other side. From information here, 350 miles would be the distance from two cities. So this would be the S, or the arc length. And the radius of the Earth, or R, would be 4,000. The problem asks you to find the radian measure of the central angle with its vertex at the center of the Earth. We are going to find the theta from the formula theta equals S over R. S is 350 miles divided by the R, which is 4,000 miles. Simplify the answer to get 0.0875. Unit is radian. Note that radian is a unitless submeasure or just a real number. If no units are showing, an angle is understood to be measured in radian. With degree mode, 3 measure, the degree symbol would be the superscript with the empty circle that's shown on the expression. For example, if theta equals 2, that means 2 radian. If you see theta equals 2 with the empty circle on the upper right, that means unit is in degrees. Relationship between degrees and radians. Recall the circumference of a circle of the radius r is 2 pi r. One full revolution, which is 360 degrees. And the circumference is the arc length or s. From this relationship, the s equals r times theta. The s, which is 2 pi r, equals the r multiplied by an angle theta. So the theta equals 2 pi. That means 2 pi is 360 degrees. Divide all by 2, we get a half revolution, or pi is equivalent to 180 degrees, and pi as a radian unit. If you find the exact amount, 180 degrees divided by pi is about 57.3 degrees. That means 1 radian. Any circle with 1 radian, the theta equals 1, which is about 57.3 degrees, where the arc length and the radius are the same. With this relationship, we can convert from degree to radian or from radian to degree. If you are given the degree angle, multiply that angle by pi over 180 degrees. Unit degree and degree will be cancelled, will give you the answer as an angle in radian or unitless. To convert from radians to degree, given the radian angle, multiply that angle by 180 degrees divided by pi. The answer will return the answer in the measure of the degrees. For example, converting the radian measure using exact values. You see the empty circle on the right here. That means you are dealing with the degrees at the beginning. So converting from 60 degrees to radian, multiply by pi divided by 180 degrees. Degree reduce. 60 pi divided by 180, that becomes pi over 3. For 210 degrees, multiply by pi over 180 degrees, or 210 divided by 180 pi, we get 7 over 6 pi. Next, if an angle theta is negative 225 degrees, multiply by pi over 180 degrees. To get negative 225 pi divided by 180 degrees, and reduce the number to be negative 5 pi over 4. Now we're going to convert from radian to degree. As you notice, there's no empty circle on the upper right, so these given thetas are in the radian. To convert to degree measure, multiply this angle by 180 degrees divided by pi. So you can see the degree symbol appears on the conversion. This will become 2 pi over 3 multiplied by 180 degrees over pi. Pi and pi simplified. 3 and 180 to be 60. So 60 times 2 becomes 120 degrees. Part B. The theta is negative 3 over 4 times pi. Convert to degree. So multiply by 180 degrees over pi. Equals negative 3 over 4 pi multiplied by 180 degrees divided by pi. Pi and pi cancel. And simplify the number. Negative 3 multiplied by 180 degrees over 4. Simplify one more to get negative 135 degrees. From 4 goes to 180 4 times and then 5 times. So 3 times 45 becomes 135 degrees. Next example, convert negative 2.3 to degree measure. As you see, no degree symbol. That means you are given the radian angle. Convert to degree measures. So the theta, which is negative 2.3, multiplied by 180 degrees divided by pi. Simplify the numbers, put in the calculator. We should get the theta as 131.78 degrees. And the question asks you to round to the next tenth of a degree. So this will be rounded to 131.8 degrees.